Let's begin with talking about some notions about sets. This is set omega, this is set A, this is set B. And the green area is the intersection between A and B, means that all elements that are in A and in B at the same time. This is omega, this is A, this is B. And now the green area is the union between A and B, means that elements that are in A or in B in addition to the common elements. And this is omega, this is B, this is the complement of B, means that all elements that are in omega but not in B. Let's see some examples. This is the first example. This is the set omega. These are A and B. We need to find A intersection B, A union B, A bar, and B bar. Well, finding the intersection between A and B means that we need to find the common elements between them, and here we have 2 in common and 4 in common, as you see. And to find the union, we put all the elements of A, then we put all the elements of B, and pay attention not to repeat any element. Here, the elements of A are from 1 to 5, and elements of B are 2, 4, 6, 8. So we just add 6 and 8 because 2 and 4 were already stated. A bar means all elements in omega but not in A. This is A from 1 to 5, so what remains is that the elements 6, 7, and 8, and similarly for B bar. Let's see this application. Omega is the letters from A to G. This is M, this is N. The question is to determine the intersection between M and N, N bar, and M union N bar. Try to do it alone. Well, M intersection N is going to be the singleton D, only one element, which is D. N bar is, we have to extract B, C, D, and E from omega, so what remains is A, F, and G. And M union N bar would be all the elements of M and all the elements of N bar, and stating the common elements only once. Let's see some probability vocabulary words. Let's begin talking about the random experiment. It's a trial that leads to an unpredictable outcome. An outcome is a result of a random experiment, and a sample space or universe, which is usually denoted by omega, is the set of all possible outcomes. So for example, if I want to roll a die, outcomes would be numbers from 1 to 6, and this is a random experiment because it's not predictable to have 1 or 2 or 3 or 4 or 5 or 6 while rolling the die. Let's see this example. A coin is tossed. To justify that this experiment is random, then specify the outcomes and the sample space. So in this case, tossing a coin is a random experiment because it's a trial whose outcomes are unpredictable. If I toss a coin, I cannot tell whether the outcome is going to be a head or a tail. Well, the outcomes are head, which is usually denoted by capital H, or tail, which is denoted by capital T, and omega, the sample space in this case, would be the pair that contains H and T. Well, a six-sided fair die numbered 1, 6 is rolled. Justify that the experiment is random, then specify the outcomes and the sample space. Try to do it alone. While rolling a die is also a random experiment because it's a trial whose outcomes are also unpredictable, and the outcomes are from 1 to 6. Omega would be 1, 2, 3, 4, 5, 6. Let's continue talking about the vocabulary words. Event, it's a set of outcomes, it's a subset of omega. So an event is a subset of omega. It contains many outcomes, and it could contain only one outcome or no outcomes. We have specifically what we call an impossible event. It's an event that contains no outcomes. We have the elementary or simple event, which is an event that contains only one outcome. and the certain event, which is the event that always occurs, it contains all the outcomes and it's equal to omega. For example, if I want to talk about the students of your class and I want to choose a student from the class who is less than 10 years old, this would be an impossible event because I'm not going to find anyone. Whereas if I want to take a student from your class who is more than 10 years old, we're going to see that this is a certain event because this event will contain all the elements. All the students would be in this set. Let's see this example. We have a fair die which is rolled, and we have the following events. Notice that the event is usually represented by a capital letter. This is a statement that describes the event. We have these four events. We need first to list all the elements of omega A, B, C, and D. And this is very important in case we can list the elements. Omega would be the numbers from 1 to 6. A, the obtained number is even, so we have to choose the even numbers from omega. This is A. B, the obtained number is greater than 6. In this case, it's going to be 5, the empty set. C, the obtained number is less than or equal to 1, so it would be the singleton one. And D, the obtained number is less than 10, so it would be all numbers from 1 to 6. Now name an event that is elementary. Which event is elementary? An elementary event is an event that contains only one outcome or one element. This would be the elementary event, which is C. Then an impossible event, it's an event that contains no outcomes, so it would be B. And a certain event, it's an event that contains all the outcomes, so it would be D. Now omega is the sample space and A and B are two events in this sample space. The intersection of the two events A and B is written as A intersection B and it's expressed verbally as A and B using the conjunction AND. The union of the two events A and B is written as A union B and it's expressed verbally by the conjunction OR. And the complement of an event A is written as A bar, this bar, and it's expressed verbally using the conjunction NOT. Now, incompatible events or mutually exclusive events, two events A and B are said to be incompatible or mutually exclusive if their intersection is phi, and two events are said to be opposite if their intersection is phi and their union is omega. So for the opposite we have two conditions, whereas for the incompatible we just have one condition. And from here we can say that opposite events are incompatible, whereas incompatible events could be opposite. And in addition to that, opposite means that A equals B bar or B equals A bar. So this is the list. AND means intersection, OR means union, NOT means bar, incompatible if the intersection is phi, and opposite if the intersection is phi and the union is omega. Let's see this example. We have a fair die which is rolled. We have a collection of events. The first part asks to list all the elements of omega and events A to G. Let's begin. Omega is the numbers from 1 to 6. A is the obtained number is even, so 2, 4, 6. B, the obtained number is odd, so 1, 3, 5. C would be 1, 2, 3. This is D. And E, the obtained number is even or greater than 5, so or is represented by the union. That's it. And F, the obtained number is odd and less than 4. This means all odd numbers and the numbers that are less than 4, the intersection. And then G, the obtained number is not greater than 5, so this would be D bar, which is all numbers from 1 to 5. Now let's continue. Name a couple of events that are incompatible. Incompatible means that their intersection is phi. So we could have For example, the couple A and F, and we could have A and B, and we might have other couples. Now name a couple that are opposite. We can see that A intersection B is phi, even and odd, and their union is omega, so they are opposite. And you can also see that D and G, this is 6 and this is numbers from 1 to 5, is phi, and their union is omega. Now let's begin talking about the notion of probability. In the sample space omega of a random experiment, the probability of an event is the likelihood or chance of the occurrence of E in omega. First, we talk about the probability of an event, and what is that probability? It's the likelihood of the occurrence of E or the chance of the occurrence of an event. The probability of E is usually denoted by P of E, and it's a value in the interval 0, 1. It's usually between 0 and 1, but it could be 0 and it could be 1. The probability of an event is 0 if the event is impossible, so P of phi is 0, and the probability of an event is 1 if the event is certain, so the probability of omega is 1. And to calculate the probability, in fact, the probability of an event, it's the number of favorable cases over the number of possible cases. Now let's see this example about calculating the probability. An urn contains 7 red balls and 5 blue balls. We need to select one ball randomly from the urn. We have these events. We need to calculate P of A and P of B. This is the urn. It's a box, if you want to say, which is non-transparent. We cannot see what's inside this box. Now, how do we calculate P of A and P of B? We need to find the number of favorable cases and the number of possible cases. Let's begin with the number of possible cases, which is the total number of balls in the urn. So we have 12 balls, and the number of favorable cases would be the number of red balls for P of A and the number of blue balls for P of B. So as you see here, the probability of A is 712 and the probability of B is 512. Let's see this application. We have a fair die. We have a collection of events and we need to calculate P of A, P of B, and P of C. Try to do it alone. Let's begin. The number of possible cases is 6 because omega in this case contains 6 elements. P of A, the obtained number is 5. In fact, we have only one 5 among the numbers from 1 to 6, so it would be 1 over 6. B, the obtained number is odd. In fact, we have 3 numbers which are odd from 1 to 6. And C, the obtained number is 7. We don't have any 7, so P of C is going to be 0 because C is an impossible event. Let's see this application. We have a pack that contains 4 green pens, 3 black pens, and 2 red pens. So in general, the pack contains 9 pens. 1 pen is selected randomly from the pack. Consider the events and calculate P of A, P of B, P of C. Try to do it alone. The total in this case would be 9, which is the number of all balls. P of A, green is 4 out of 9, and P of B, red or black. Well, red or black, we have to add the red and the black. We have 5 over 9. And C is not green. If it's not green, so it's going to be either black or red, so it would be also 5 over 9. Now let's see this application. The T family has 2 parents, 1 father, 1 mother, 2 sons and 3 daughters. So we have 7 persons in this family. 1 person is selected randomly from the T family. Calculate the probability of selecting a male from the T family. Try to do it alone. In fact, we have 7 persons, and out of these 7 persons, we just have 3 males, which are the 2 sons and the father. So the probability is 3 over 7. Now calculate the probability of selecting a son from the T family. We have 2 sons out of the 7 persons. And calculate the probability of selecting a parent from the T family. Try also to do it alone. In fact, we have two parents, so it would be 2 out of 7. And finally, selecting a person from the T family who is not a parent. Not a parent means 5 over 7, which are the sons and the daughters. Now let's see the properties of probability. This is omega again, A, B. We have the intersection. This is A, B, and this is the union, the green area. And this is the complement. Now, till now we know that P of omega is 1, P of phi is 0, and the probability of an event is a number that goes from 0 to 1. Well, P of A plus P of A bar is 1. This is A, as you see, and this is A bar. So if we add the two probabilities, would be the probability of omega, which is 1. And from here, we can tell that P of A bar is 1 minus P of A, or P of A is 1 minus P of A bar. Now let's see the union. This is the probability of the union, A and B. This would be the probability of A, the whole set of A, plus the probability of the whole set of B. But in this case, we're going to have a redundancy here. Some elements would be added twice. That's why we subtract the intersection. So it will be all A, all B, but we have to subtract the intersection because it's repeated twice. And from here also we can tell that P of the intersection, if this is the intersection, this would be the union. Just flip the two probabilities. This would be the union, and the probability of the union plus the probability of the intersection would be the probability of A plus the probability of B. These are the properties. Let's see some examples about them. Omega is a sample space. A, B, and C are events such that P of A, P of B, and P of the intersection. The question is to find the probability of the union, so we use the second property. The union is A plus B minus the intersection, so it would be 2 over 5. Now P of B bar, we use the first property. It's 1 minus P of B, which is 7, 10. Let's see this application. We have omega and some events. We need to calculate P of M intersection N bar. Try to do it alone. Well, the probability of M intersection N bar, if we apply the second property, this would be the probability. And in fact, we need here P of N bar, and it is 1 minus P of N. And we know M union N bar.